Hey gang, welcome back to the channel. All right, so in last week's episode, we started to put together the asset initialization functions, and we were in the middle of creating the pipeline state. And we had basically gone through and created our vertex and pixel shaders. What we need to do to finish off the pipeline state is basically tell the video card what format to expect the vertex inputs in. So you can send vertex inputs in any format you want. It's really very, very flexible. For different applications, you may send different things. We're going to send basically 2 parameters per vertex, so we need to tell the card that. The card also needs to know about these shaders. We've created these shaders, but we haven't actually sent them to the card yet. So that's what's going to be. That's what we're talking about when we say we're going to create the pipeline state. It's basically the vertex input formats and the shaders. So that's what we're going to be doing. Okay, I need to move this. Hang on just a second here, gang. Can't see my keyboard. Okay, all right. So let's start off with setting up those vertex input layouts. So I'm going to create a. Let me just take a look at what I'm doing here. Yeah. Okay. Let's come up here and we're going to create a D3D12 input. This is the wrong element description. There it is right there. Okay. This is the structure that we're going to use to define our vertex inputs. So we'll call this input element desks, and I'm just going to give it a 2 here. I probably should make that a constant variable of some sort, but it's not. That's a little bit of overkill. And just to make the compiler happy, we'll just clear it out to 0, like such. Okay. All right. I'm going to put some stuff in here. So input element desks dot. Oh, wait. Before we do that, 0, we're going to set up the first one. Semantic name. And I'm just going to leave it at that for right now. I'm just going to actually copy this down a few times. Let's see. 1, 2, 3, 4, 5, 6 times. 6 times. 3, 4, 5, 6. Okay. And it's going to mess up all the stuff, but that's fine. Okay, so semantic index format. I'm just going to set these up, and then I'll talk about what they are. Input slot, aligned byte offset, input slot class, and finally instance data step rate. Okay, there you go. And actually, I'm going to grab this all 7 of these. I think it's 7. I'm going to put them in again. It's really messing up my things. Okay. And I'm going to just switch this to the second one. Awesome. Well done there. Okay. You could, guys, just as easily use a initializer list. Like I could just set these up in here. I have nothing against initializer lists. They're fine. I mean, I use them myself, so don't get me wrong. If you want the code to be a little more compact, instead of writing all this out, you could just use an initializer list. The con for me for initializer lists is that you lose the names. So I'm going to set all these up, and if we used an initializer list, all we would have is what these are. We would lose all these names, and the names are kind of helpful sometimes if you don't really know the structure. Now, if you want to use initializer list, be my guest. That's totally fine. for me, I will use initializers lists when I don't really care about what the names are, and I will be doing so. So anyway, we need a semantic name. So this is just the name of the what are we going to call it? The name of the vertex input. So we're going to start off with a position, and then the second one, I'll do these by type. We're going to give it a color. So we're going to have two semantics. Damn it, dude. Why are you doing that? We're going to have two semantics. We're going to have a position and a color. Okay. So that the semantic index is going to be 0. What the semantic index means, you can have more than one position. So if I could put a semantic name. If I were to put position here, would increase the index. Each one of them has to have either an individual name or an individual index. So if I put position here, this would have to be index 1. But since these are two different semantics, we can put 0 for both of them. Quit messing with my thing, you bastards. Okay, so yeah, that's what that means. Okay, so we've got a position and a color. Now it wants to know the format. A position basically takes 3 floats. Yeah, we'll leave it at that. I mean, you can get more complicated than that, but for right now, we'll just leave it at that. I don't want to get too deep into this. So we set up a DXGI format, and we're going to say red 32 bits, green 32 bits, blue 32 bits, and these are going to be of type float. These are not really colors. The red, green, blue. These are positions in space. And I believe they're defined in model space. I think they're defined in model space, and then you switch them to world space through matrix math. If I remember correctly. It's been a while, but yes, I think so. Okay, so the format for a color is going to be very similar. DXGI format. But this time we're going to do four floats. So it's going to be red 32, green 32, blue 32, and alpha 32. So it'll have an alpha component float. Now these really are colors, right? So that's how we're going to define a position and a color. Now, given our vertex shader, it's only really using the position. The color is not going to do anything, but we're going to have it just in case we need it for something. We may use it later on, so we may as well define it. Okay, the input slot for this is going to be 0, which is going to be the same for this one. Honestly, I don't remember what the input slot is. I have to look. Let me take a quick look. See if I can remember what the input slot is. Okay, yeah. The help instructions say it's an integer value that defines the input assembler. Okay. I have no idea what that means, but sure. We've just defined the input assembler slot. Who cares? Okay, the align byte offset is where we tell the format where this is going to live. So this is the first semantic, so it's going to be the offset's going to be 0. But this one, the offset is going to be 12. Why? Because we have 32 bits here, which is 4 bytes. So there's 4 times 3 bytes here, so that's 12 bytes. So the aligned byte offset is going to be 12. I think the alignment has to be word aligned. Could be wrong, or maybe byte aligned. If it's byte aligned, I'm not really sure. Let me see if the instructions say anything. Yeah, I guess it's byte aligned. I mean, I guess you could have a bit level format that takes up part of a bit, rather than maybe it takes up a byte and a half, and then you would have to pack it to get this to be the right spot. It has to be byte aligned, which is sure. why not? But we don't really have to. We could just as easily set this to -1, and that would automatically do it for us. But yeah, you know, sure. It's a uint, so it's not actually -1. It's actually like a bunch of f's. Really is what it is, but it's essentially -1. Okay. So yeah, there's your byte-aligned format. Now the input slot class. We're going to say D3D12 input classification. This is going to be per vertex data, which just means there's going to be one of these per vertex, right? And same thing for the other one. We're defining these by vertex. And then the instance data step rate is just 0. I honestly couldn't tell you what that means. And I don't really care. And there you go. So we've just defined the vertex format. It's going to have a position and a color. The position is going to be 3 32-bit floats. The color is going to be 4 32-bit floats. And that's basically all we need. And then it just needs to know where the position ends and the color starts. And that's what this tells us. So yeah, there you go. That's all there is to it. Okay. So we've set that up. Now we're going to say, let's see, here we're going to say, let's comment. Define the vertex input layouts. Here we're going to describe and create the graphics pipeline state object, the PSO. Okay, this is where we're actually going to send, well, we're going to be sending things. Okay, we got to do one more structure before we can actually send it to the card. But this is where we're going to put everything together, kind of. So let's put in here D3D12 graphics pipeline state description. That's this one right here. So we'll equal to PSO description. And just to make the compiler happy, we'll put in the brackets to do that. Oops, equals. No equals. There you go. Okay. Let's start setting this up. PSO desk dot input layout equals, and I'm actually going to use an initializer list here. This actually has two inputs. I'm just going to, I don't care what their names are. It's just the input element description, which we just set up, desks, and then count of input element desks. This is how we tell the graphics card. Like we set up this structure, this is where we're going to actually send it. So we've put it into the PSO description, right? So there you go. P root signature equals, this is where we use our root signature that we created before, dot get. There you go. That's easy enough. PSO desk dot so VS means vertex shader, obviously, equals. All right. So again, we're going to use an initializer here. So this is a little bit tricky. We need to send it the buffer of the vertex shader. But to do so, we need to send it as a unsigned int 8, right? So in order to do that, we need to do a reinterpret cast, which you know, nobody likes green overcast, so I get that, but in this case, that's what you got to use. So, and then it's going to be vertex shader get buffer pointer, and that's how you set that up. And then for the second parameter, we're going to get the vertex shader get buffer size. Got to send it the size of the buffer as well. And that's how the card is going to know what the vertex shader is. I'm going to copy that line down, and we're going to do the same thing for the pixel shader. Except instead of using vertex shader, we're going to use pixel shader, right? Like such. Okay. So we just set up our vertex and pixel shaders. PSO dot rasterizer state equals. For this, we're going to use a helper function. So C D3D X12, of course, underscore rasterizer desk. And I'm just going to say D3D12 underscore default right here. Okay. The rasterizer state's just going to be in the default state. And I'm just going to copy that down, and we're going to do the same thing for the blend state. This is going to be blend. Damn it. I want you to leave this alone and just give me this part, blend. And yeah, we're going to set that to default. I think that's right. CD3D blend desk. Yeah, that should be fine. Okay, PSO desk dot depth stencil state dot depth enable equals false. We're not going to enable the depth stencil. And I'm going to copy this and use the same thing for stencil enable. We're just going to turn those off for right now. We may turn them on later on. You know, this is not a hyper advanced like 3D game. We're basically creating a 2D game here, right? So a lot of this stuff is not really for us. Don't get me wrong. There's going to be some 3D elements to it, but it's not going to be. We're not building like, I don't know, Halo or anything like that, right? So PSO desk. Let's keep going with this. Dot sample mask equals uint max. There it is. Honestly, I'm not quite sure what that is. So yeah, I'm not gonna comment on it because we don't need it. Just gonna leave it the way it is. Primitive topology type equals D3D12 underscore primitive topology type triangle. Basically, we're telling it we're going to be sending it triangles. Is what we're saying here, rather than points or line segments. So yeah, PSO desk dot num render targets equals one. Just one render target at the moment. That may change. I have some thoughts about that one, but yeah. Okay. RTV formats. Sub-0. Sub-0 equals dxgi underscore format underscore red 8, green 8, blue 8, alpha 8 underscore unorm right here. Yeah, basically what we're saying here is that we're giving it 8-bit red, green, blue, and alpha for the render target. I know it's it's not. Don't worry about it too much. It's just the render target is going to be in 8-bit format. There's a lot of stuff here that we don't really need to worry about too much. Sample desk dot count equals 1. Okay, there you go. It's a lot of stuff here, but the important things here, guys, is we're giving it the this vertex format that we just created. We're giving it the root signature, and we're giving it the vertex and pixel shaders. The rest of this stuff we don't need to worry about too much, right? So there you go. All right, now after all that, we finally get to send it to the graphics card. So we're gonna call on the device, create graphics pipeline state. There it is. Underscore, and then we're going to give it the address of the PSO description. Okay. So this is going to give it all this stuff. Okay, this is actually going to the graphics card finally, and then we're going to go an ID PPV ARGS. This basically, guys, is a reinterpret cast. We're just hiding it behind this fancy thing that we're doing here, but it's a reinterpret cast for these COM pointers is basically what it is. Okay, so pipeline state. Okay. And then since we've got a fail state possibility, we will go ahead and drop that in. Just create pipeline state. There you go. Okay, it doesn't know what pipeline state is, obviously, so we have to tell it. Let me just make sure I'm doing this right. Okay, so go back over here to our asset objects, and we're going to say COM pointer D3D12 pipeline state pipeline state, and there you go. I think we're good, and that should be happy. And there you go. That is all there is to do for that. I think we should be able to run, and everything should work. And yeah, it seems to be working fine. So there you go. We have created our graphics pipeline state. Very nice. Okay. Very good. The next thing we got to do, guys, I'll probably get... yeah, we'll get like one more function done. I think this will be a 3-part series to create the assets. I think. Anyway, we're going to create a command list. The command list is the thing that you fill in to tell the graphics card exactly what to do. It's really not much more complicated than that. It's a list of commands to the card. Okay, so we're going to go ahead and create Let me just make sure that I'm doing this properly. Yeah, it's fine. Okay, let's go down here. Asset initialization function, and we'll say bool create command list, which should make this happy. There you go. And then I'll copy that. And we'll head back down to the bottom where we're going to actually set up the function. Okay. Let's make it a part of the class. And we'll give ourselves some sort of comment here, which I think is going to be nothing more complicated than creating the command list. Let me see. Create the command list. Yep, that's exactly right. Which is, I know, it's a little bit silly because you can look right here and say it's creating the command list, but whatever. It's fine. I like to have some sort of comment at the top of my functions. You know, even when they're stupid. I get it. It's because I think by doing that, if I hover over this, maybe not. If I hover over the function call, let's see, where's it at? Yeah, it gives me the comment. So, you know, it's kind of useful, sort of, kind of. Okay. This is a fairly easy function, so it shouldn't take us too long. There's basically two calls that we're going to make for this. Essentially, if failed, and we don't have to set up a bunch of weird structures that we have to fill in. So we're just going to call on the device, and we're going to say create command list, and then some parameters. And then since we're going to have a failed state, I'll drop that in. Create command list. It's the same function name. So we just got to fill in our parameters, which we'll get in just a minute. So I'm going to put a comment here. Command lists are created in the recording state, but there is nothing to record yet. The main loop expects it to be closed, so close it now. That's right out of the Microsoft page that I'm kind of basing this code on. So yeah. Anyway, I'm just going to copy this function down here, except we're going to say, instead of create command list, we're just going to say close. Oops, that was too many. Close. That's all there is to it. And instead of this is going to be this. Paste that in, and of course we have to return true here, otherwise it won't work. Why does it not like that? There really isn't anything else. Oh, because I said device. No, it's the command list. Command list. That should be happy, I think. Well, no, because it doesn't know what command list is, does it? So let's we're going to create the command list. So let's create that under the asset objects here. And of course, it's going to be a COM pointer. D3D12 graphics command list and command list. Okay. And now it should be more happy than it was. Indeed. Yep, it's fine. Okay, good. So the only thing really left that we need to do here is set up the parameters for the command list. So fairly straightforward, I think. Let's see. Okay, yeah. Okay. So the first parameter is a node mask. We don't need a node mask, so we're just going to say 0 there. The second parameter is the D3D command list type. So we're going to say D3D12 command underscore list type direct. It's basically direct commands. Okay. The next one is the command, a pointer to the command allocator. So we have a command list allocator already. Command list allocator. We already set that up. Whoops. It's not a pointer yet, right? The command list allocator we set up back in the pipeline objects. So that's this guy right here. Okay. And then the next thing is the initial state of the pipeline. So we're going to say pipeline state. Yep, that's the pipeline state that we just set up right here. And then we'll say get. And then IID, PPV, ARDS, the address of the command list, which is going to be created. And that should, I don't have nearly enough closing brackets here for some reason, because I screwed around with the thing. So let's see, this should be 3, 1 more, I think. Yep, there you go. All right, there you go. We've created that. I think we need to, we called it already. Okay, yeah, we've called it. So yeah, let's go ahead and see if it works. If I didn't screw anything up, we should have a command list now. And it looks like everything's working. I just like to wait for the stuff to come up just to make sure that, but yeah, it should be, looks like it's fine. Yep, all good. Okay, we still, after all this work, we still do not have a triangle on the screen, but we have the format, we have the vertex and pixel shaders, we now have a command list all set up and ready to go. So yeah, we're doing well here. The only thing we're missing really is the vertex buffer itself for objects. And that's going to take a little bit of setup. Yeah, that is going to take a little bit of setup. But once we have that, I think we're in good shape. I think we can start thinking about moving on. I think. Just looking at my list here. Yeah. We'll create the vertex buffer. We're going to do some synchronization stuff. But yeah, I think we're getting pretty close to being done with the initialization. So, but I'm not going to go on with that. We'll do that maybe next week. And yeah, I think we will go ahead and stop here. I think. Yeah, we'll go ahead and stop here. And we'll pick this back up in the next episode. We'll finish off the asset creation. All right, so we'll stop here, and I'll see you guys in the next one. Thanks a lot.